Okay then, so we're back for more, and this time we're going to be having a look at the OpenAPI specification. So in this part of the course, I've been working on design and documentation, and the OpenAPI is going to play a big part in what we do in this section. So let's first just have a look at what it is, talk about what I'm going to cover in this one. So not Spotify. Okay, so PHP Pro live stream number 4, OpenAPI plus Swagger. We're going to have a look at what OAS is, and then we'll talk about the different approaches to designing and documenting your API. So we'll talk about code first and design first. Then we'll talk about something called API first, and a couple of examples of what that is. And then we'll look at all the different components of an OAS document. And then at the very end, we should have a complete OAS. And then we'll just have a little talk about what progress I've made with the course, what I'm working on at the moment. And then also we'll do a giveaway like I did in the last live stream. So open OAS documents. If we go back to the site, like it says on the site, it provides a formal standard for describing HTTP APIs. So what that means in real speak is that it just provides like a specification and a format which everyone can use. It can be read by humans and it can be read by machines. And what it will do, it will show you, it has things like it describes what your API is about, but it'll also tell you things like what the paths are, gives you information on security, things like servers, and all the different parts which make up your API is all documented in an open API specification document. Can be shared with the team. Like I say, can be dropped into software and read by machines also. And so this is like an industry standard document, and there's different ways of producing these. You can produce them by first creating them using an editor or whatever, or you can also, they can be produced actually by your code. So if you think of something like what is it, API platform, uses attributes to sort of document the entities or the resources. Well, behind the scenes, what that does, it will actually take that information and produce an open API specification. You can also use like Swagger annotations or Swagger attributes to automatically generate these. And so that's what we're talking about when we talk about code first versus design first. So for the course, what we're doing is we're taking a design first approach. So we're actually going to go and actually create this document using the Swagger editor. But like I say, if you're taking a code first approach where you're sort of writing the code as requirements are being sort of generated and discovered. And so with the design first approach, you pretty much know what all the requirements are going to be before you start writing code. Whereas the code first approach is more of an iterative approach, more like the type of thing you'd sort of do in like a startup or something which needs to be built and got to market quickly. You might take a code first approach, but I prefer to take a design first approach. It means less rework. It often means less versions, because you might start working on something, blast out some code, realize the requirements from the actual consumers of the API might be different than what you imagine they would be. And so then you're having to start introducing breaking changes and introducing different versions of the API. So design first is my preferred way, but it's not always the option to you. And then we have something called API first. And so API first, it will use a design first approach. However, it's not just a development a development approach, it's also a business approach, because with API first, you're placing the API as your product. And so before you even start working on it, you're going to gather all your requirements from all your stakeholders and everyone. And the way you'll do that is with one of these specification documents. So it's a collaborative document. You put it under version control. Developers contribute to it. The business contributes to it. And everyone really. It's a shared document which will then be used to take that and design your API or build your API with it. And with this document, one of the pluses is you can sort of work in parallel, because when you create it, you have all the information there needed for backend to go and produce their work, but also front-end developers have the contract there, so they can actually go and start their work. So work can sort of happen in parallel when you're using these documents, when you're taking a design-first approach. So I think that's all the information we need to get started. What I will say is that these documents can be created in two different formats, YAML and JSON. I think the most recommended way is to create them in YAML. Much easier to read in YAML, and they, like the official OpenAPI initiative, does recommend using YAML. JSON is possible. I've used JSON, but with all the opening and closing brackets and all the nesting and everything, I find them really hard to read and potentially easier to make mistakes with. All right, so let's make sure I've covered everything that I wanted to mention there. Yeah, a couple of things I forgot to mention. So with the API first approach, where the API is the business, think if you want examples, the examples you can think of are things like Stripe or Twilio, where Stripe is the Stripe API is the business, Twilio, their API is the business. Right, so let's start dropping some components into this. So we'll go and have a look at what we've got here. And first, we'll have a look at a full OpenAPI spec. So here's one. This will be the finished article, which we'll look at the end of the recording. But here, let's just have a scroll through. It looks pretty scary at first, all this information in here, but it'll all make sense by the end of this. So here you can, the various different sections. So you have information, which gives you a summary of what the API is, servers where the API can be reached at, tags, we'll talk about that in a minute, paths. I'll talk about all these components as we go and add them. So the first thing we're going to add, or the first things that we need, if we go back to here. So every OpenAPI spec needs to start out with this. You need to define that you're using an OpenAPI, which actual language you're writing this in, and then the version. So there is a version 3.1 point whatever, which is the latest, but for whatever reason, the Swagger editor will only accept 3.0 or 3.0.3 at the moment. So we'll do it in that, but they are fairly similar. If I was going to use a different tool, I'd probably do this in 3.1. But this one's the easiest to actually, it's the easiest on the eyes and the easiest one for me to present to you. So we'll go ahead with this. All right, let's start dropping a few parts into here. So the first thing I'm going to need is the information regarding the API. So this will contain all kinds of sort of vital information. If you was to start working on this, or you were being brought up to speed with a project, this is the summary of what the API is and what it does. So here we've just got some info about the title, what is the name of the API, description of what it is, what it does. You can put links in there which are clickable, and also the version. So not to be confused with the OpenAPI version, this just means the version of this document. So like I say, you put these under version control. This one that I'm creating will live with the PHP API Pro project. You'll be able to grab it from GitHub with the rest of the code. And that's typically what you would do with these. It would live with the actual code, the actual API itself. But an important thing to note, or you'll have noticed, On the left-hand side, I'm creating the spec, but on the right-hand side, remember we said that these things are machine readable. Well, this is producing like Swagger documentation for us live. So as we drop these parts in, the right-hand side will be updated with like a human readable or more human readable, better presented for humans on the right-hand side. Okay, so info, I think that's pretty easy to understand. The info section provides metadata about the API, including title, description, version. Fairly straightforward. It will get more interesting than that. So let's grab the next bit, which will be servers. And so these are the base URLs for the API. And so for the example I've used here is to use like URLs for different environments. So you might have like a pre-production environment or staging, but you can use these for wherever you might be able to reach your API at, whichever servers, whichever URLs. And so as you can see, it's created a drop-down menu on the right-hand side. It's read this and being able to do that. So that must be how Swagger sort of reads arrays or reads arrays under the servers section. If you're unfamiliar with YAML, this is just change my computer there. This is how you define an array in YAML. So you have your key, a colon, and then each part of your array, you use like a hyphen for each different item. All right, servers was pretty easy to understand, I think. Let's move on and have a look at our next bit. And so the next part will be tags. Okay, and so this is used to group related operations, and this basically just helps us stay organized. So when I drop that in there now, you'll see that we have 3 sections. And so I've given the resources that we're going to use for this API. We're not going to have millions and millions of resources because at the end of the day, it is a learning project, but we're going to have a flight, we're going to have reservation, we're going to have passenger. So a reservation is related to a flight and passenger is related to reservation. And there'll be enough there for us to be able to show all the filtering and sorting and all the things that you would do with data. That will be plenty. But yeah, like I say, it's now created these sections on the right-hand side here. So by using those tags, we can now tag our operations and it will drop them into these sections. And so that takes me on nicely to paths. So here, while I'm just showing you this and demoing this, we're just going to drop in just the flights. We'll not drop the reservations. We'll have a look at the full spec for the full API and a full display of the Swagger stuff at the end, but for now we're just dropping little pieces in bit by bit. So this one's a bit longer, and this is the paths section. So the paths section, as you will have guessed, is where you define all your paths, i.e. your endpoints. So it defines the available paths in the API and the operations that can be performed on each path. So you start off with a paths key, and then whatever your path looks like. So for ours, one of the paths will be just /flights. And if you remember the sections on resources, we said that that could be used for when you're retrieving a collection of flights, or if you're posting to create flights, we will use an endpoint which looks like this. If we were looking for more specific flights, which is something I'll demonstrate later on, what you would do is you would have an identifier after that. But this is just the endpoint to get a collection of flights. And then the operations on that, here is a get operation. And you'll notice that I tagged this with flight, and what that means is it drops it into this section under flights. So it's so clever how this can be read by both humans and computers, because it just enables to do this and make it really easy. Looking at this documentation on the right-hand side, just what each operation does, what the parameters are and things like that. So let's click on this drop down and we'll show you some of the things that we've got in here. So you'll notice that I said what content it will return or will accept, and then we've said what the response will look like. So this is what a 200 response would look like. The description is successful operation, and then this is, I'll just make a bit more room here. This is what the actual content should look like for a successful request to this endpoint for a collection of flights, and that is defined here. So you'll see we have properties, flights. So we gave it the flights key. If you remember, we decided that's what we're going to settle on earlier in the course. And then for each of the properties, it tells you what sort they are. So we're saying it's a string, and then I've given it a pattern, so it must match that pattern, and then we've thrown an example in there. So it's pretty cool how you can put examples in there, because that really just helps another person understand, okay, I know what that data should look like now. And so, for example, date time here, and we've put the example in there to show that it's like an ISO. Is it 601 or something? You call these date times? Yeah, so an ISO date time there. Yeah, so that is basically how you will define an individual operation for a particular path. So, as you can see here, I'll just make sure that is the section I was going to talk about next, in fact. Yeah, so as you can see here, we have this information regarding the actual schema, what the data will look like when it's returned. But if you can imagine, that we're going to be using this over for a lot of the other operations, we're going to be reusing, especially the part here where it is the actual data relating to an individual resource. If we make a post request, if we make a put, if we, not a delete, but if we do a get request for a single flight, if we do a get request for a collection of flights, if we do a post or a put, we're going to get this information back for each of those operations, which means, do we want to keep having to rewriting this for every single operation? That would be a lot of duplication and potential to make mistakes. And it means if you've got to change it in one place, you've got to go and change it in other places. So that won't be ideal. But the good news is that OAS has got your back, because we can use something called components, reusable components, where all we would do is just reference it like we are doing on this line here. So I'll show you how this works now. So I've left it commented out at the moment, but what we can do is we can go, and I've already created a components section for this. So what I'm going to do is I'm going to go and cut this from there. So as you can see on the right hand side, that's disappeared. But now what we're going to do is we're going to create a component. And so here, as you can see, we have this component section. Under that, we have a schemas key, and then we have defined an item or a schema in there called flight. And all this information here, it's all just a match of what was previously put on the individual operations. So like it says here, the component section of an OpenAPI spec document is a container for various reusable definitions. And so again, it helps us avoid duplication and maintain consistency, and it's commonly used with schemas. Okay, so the way that we use this now is all we need to do is just reference it. And the way we can do that is we just reference components, schemas, flight, and you use this ref key, which is like a little magic key to do that. And then when I remove that comment, as you can see, it's magically reappeared. So here, instead of putting all of this stuff under each operation, you can reference other parts of the same document, but you can also reference parts of other documents. So you can create like a little bunch of components if you don't want to put everything in one document. And so if you, for example, you just wanted to have one document which contained just this flight schema, you could do that. And then if something changed regarding a flight resource, then you'd only need to go and make that change to that document in that one place. And as long as you're referencing it, then your whole schema will be updated everywhere. All right, so that's pretty cool. Now let's have a look at parameters, because if you look at our flights, there's a few different places where you can put parameters, but the main ones we're going to have a look at here will be path parameters. So if you think about when we have flights followed by the number to get an individual flight, we would have a path parameter there, which would be the number. But when we get onto filtering and sorting, we will also want to use query parameters so that we can, for example, if you want to filter flights just by origin or by destination or by departure date or something like that, we can use query parameters for that. So let's go and have a look at parameters. So this is what these look like. Like I say, used to define input parameters that can be accepted by an API endpoint, and so it can be included in the path, the query string, header, or the request body. In this one, we'll be looking at parameters which are in paths and query strings. And so this is how you define them. So here we're saying parameters, and for this particular one, this is for filtering a flight by flight number. We will be looking in the query string for the number. So for example, you could say flights, and then the number is blah, 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 and it will just get you flights with that number. Again, you can filter by origin, destination, departure time, and you can choose what you want to filter by. It all depend on your business requirements. So let's go and drop this into here. I've left a little placeholder, and this will make sense when I drop it all in here. I'll probably need to sort out the indentation a little bit. Okay, so that has dropped those into there. The best way to be able to see the effect is to actually, I'll just click try it out, and I'll just change some of these. And so we'll say we'll filter by origin, for example, say AAA, and then execute. So this is not connected to a server or anything at the moment, so it's not going to actually make a request. However, what it will do is this: it will show us the endpoint or the request URL. So like I say there, we specified that as a query parameter. So the one that we're looking at is this one, in query string name origin. So as you can see, origin, and then you say what type it's going to be, and then there's a little description there of what you're doing. So here we're filtering by origin, so we could ping this flight's endpoint and get only the flights which actually take off from this airport AAA. So hopefully that made sense. Let's have a look. I think that completes all of the parts that I was going to show you for this one individual flight endpoint. What I'll show you now is maybe the whole spec, and we'll have a look at some other parameters and some other things which you can actually drop into the schema. So let's grab the whole flights spec. We'll completely overwrite that, and then when you have a look now, you'll see that we have sections or endpoints for flights. Close that up. We have reservation, and we also have passengers. So we've got the full suite: get, post, get individual items, delete individual flights, delete, put, and patch. And the same for reservations and the same for passengers. But I'll also show you some other things here. So if you find flight's number, I'll show you a different kind of parameter. So I'll scroll all the way up here, and I'll just close up that one. So here, flights number, and if we come down to parameters here, this time we're saying the parameter is number, but instead of saying in query like we did for the previous one where we were looking at origin, we're actually saying that number is in the path. So as you can see, that number. So it's a path parameter rather than a query parameter. And another thing you'll notice here, let's just open this up, is I've used a schema for the flight number, because as you can imagine, the flight number, it's going to be used a lot. We reuse it for all of these endpoints number, and it's quite a long number with a particular format. So I wouldn't want to be creating an example for every single time I want to show it. So again, I've used another component schema, flight number. And what else can I show you about this one? That's get flights number. I'll show you something on the get endpoint now. We've dropped all of it in there. We also have some extra parts at the bottom here. So if you remember in like the first chapter of the course, or the first parts that we spoke about when I did the first live streams, I may have mentioned hypermedia. There's certainly examples on the course page, but if you're creating like a REST API, or they sometimes refer to ones which include links as a hypermedia API, but technically all REST APIs should include hypermedia. And if we're getting a bunch of flights, there could be hundreds of flights in the database, can't there? And so we're going to include pagination, and the way that I've done this is by adding links. So you can link to the first page, the previous page, next, last, and then you will have metadata which will tell you how many items there are, how many total pages, what the current page is, and how many items will be on each page. And the way I've done that here is I've done the same thing as what we did actually using schemas. So down at the bottom here, where we have the response, this is for a successful 200 response. So we have what I showed you before, which was the response schema. But in addition to that, I've also used the components schemas in order to create a links schema. So I can just reuse this wherever I need it, and it will just drop it in there for me. All right, so there we've just created a whole OAS. So they look a bit scary at first, but when you actually have tools like this, you can also do this with Postman. I've tried it out with Postman. It wasn't great, to be honest. And I've also, you can do it in PHP Storm. So here you can see we're just looking at the actual, the YAML, but if I click in the top right-hand corner, I get a very similar thing as what I'm getting with the Swagger editor. The only main reason why I didn't use this one and I used the Swagger editor online is just because that one is easier to read and probably a bit more responsive. Actually, I think you have to keep refreshing PHP Storm when you make any changes to the spec, whereas this one, it's obviously using some JavaScript, so it's just updating live as I add different parts to the specification. And so, yeah, apart from the paths, there's also other sections which you can add. And so, like we say, we've had a look at components. We've looked at servers, tags. Another big section is security. So down here, we have a section on security. I think I've got actually a bigger one somewhere on security, but we've not actually covered security in the course yet. There is actually, it's just above that. We've not covered security in the course yet, so we are taking a design first approach. However, we might not be designing the entire thing first, because there'll be things that I haven't yet sort of taught in the course, which I won't be able to add to the document yet because it wouldn't make any sense to you. But we will add a few bits as we go along, but most of the operations that we're going to cover are actually added to the document. And the main things that we'll be interested in, or one of the main things, will be the actual paths and the operations and making sure that that stuff all works. All right, so I hope you found that useful. This OAS schema is attached to the repo on GitHub, or it definitely will be attached to the repo on GitHub at some point, maybe in the next couple of days, if I haven't already done it. I think I did. Sometimes I lose track. And yeah, so the next part of the course I'll be covering will be on error handling and validation. So I've been having some fun with that this week. I'll show you some of that stuff in a moment. But first, let's just make sure that we've covered off everything that I said we were going to cover off in this one. So I've looked at components. I've shown you the complete OAS. Yeah, like I say with the course, what we're up to now is, or what I've been working on this week, is error handling. So we've been looking, or I've been looking at the problem details specification, and just making sure that the error messages which are sent back from the API are of a good standard and that they are consistent. And so one of the ways to do that is to just stick to a specification. And there's one which is ready-made for us. It's called problem details, and it just lays out ways in which you can respond with errors. And here is an example. So instead of just sending back like random information, these are all standardized keys. So type should be a URL which points to where someone can read more about the error. Title will be what the error is, detail, a little bit more detail about it, and then instance will be the resource. And then you can, for certain types of errors, you can embellish them a bit with extensions. For example, this validation one here, which is similar to what we're going to have a look at, or what I've been building this week. And to those kind of things, you can add a bit of extra information, such as what the errors were. So that one's going to be a lot of fun. We'll be a lot more code in that section. We'll write a lot more code in that section than what we do in the design and documentation section that we've just been working on, or that I've just been working on, which is mainly a lot of it just theory, and as like you've seen, the OAS document and the Swagger editor. All right, so I think that covers everything. Let's see, we've got Brazil in the room. We have Cambodia, and we have Ecuador. Welcome, welcome, guys. All right, shall we do a giveaway? So the question is going to be this: the first one to answer wins. So towards the beginning of the video, I mentioned that OAS specs can be written in two different formats. Basically, to win the giveaway will be one of my existing courses, any of my existing courses, plus the PHP API Pro course when it's released. So to win that, just let me know which formats an OAS spec can be written in. There's two different formats. All right. And so that pretty much wraps it up. Okay. So I don't think there's any questions. The next live stream will be regarding the problem details thing that I've just been covering, and also just error handling in general. Thanks for tuning in. I hope you enjoyed it, and I'll see you in the next one.